Hi, today I would like to show you a tutorial about free loads in SCIA Engineer. The input for this tutorial was a request from a customer, and he asked to input a single vertical point load on a wall somewhere in the middle of the wall. And I think it's good if I explain everything or the main things about these free loads. My name is Ivan Beleš and I am support engineer for SCIA Engineer and Idea Statica. What are free loads? Free loads are loads that are not directly connected to the geometry of your structure. So you can draw these free loads somewhere and they will be projected like, you can imagine like an X-ray, and this will be projected on the structure. You can define on which 2D parts this will be generated, how is the depth, and if you select it or not. And what is also advantage in comparison to standard, for example, surface load is that for free loads you can generate a trapezoidal intensity with X and Y direction or with 3 points, so it's more general. And as I thought, they are not connected to the structure, so you can use it, for example, if you need, if you have a big slab and you want to define a partial loads, for example, for this chess like distribution of live loads, or you have, for example, a cylinder like a silo and you want to generate water pressure, or you want to generate earth pressure or something else. These free loads are used also in the 3D wind generator. So, and now we go to SCIA Engineer. I have prepared some example structures and I would like to generate the loads on this structure. So first, where you can find the free loads. If you are in all text, for example, and all workstations, then it's somewhere here between the loads. So you can simplify this and you can go to loads if you want, and you can also simplify it more and go to, for example, to basic modeling. Then you see only the necessary things for us for today. So the first task is to generate a load on this slab here, but not on the full slab, but only on this geometry which is drawn by the lines. This is also a standard case. You get some DXF or DWG file and you import it and draw your structure. And these rooms must be really the same geometry like your outline of your slab. So first we want to generate it. What we have to do as a first step is to move the coordinate system to the place where I want to generate or where I want to draw the free load. First we will concentrate on surface load. The line loads are the same input. First I have to move the coordinate system. So we go to coordinate system, move and select this point. So then this load will be drawn on this level. And now we can go to free surface load, define the direction. It's a force, it's okay, it's uniform. Also, if you want to define later some trapezoidal intensity with these 3 points or X and Y direction, first it's better you start with uniform, because you have to select which node have which intensity, and before the load is drawn you don't have the node. So better you start with uniform, some intensity and the validity. What is this validity? This load which I will draw is like a generator, and it can act only on this one slab. This is in the case I select Z is equal 0, and selection is auto. Later after it's defined, you can change the selection, for example, to selection, and then you can click on some plates which should get this load. So I select it on Z0, and this global coordinate system is on length or projection, so you can select it. So, and now you see here are the possibilities how to draw the geometry. You see this is the same like you would like to draw a slab. So you are not limited on rectangles, you can draw everything what you want. So I start with this point. You have to select the correct snap points, of course. So this one and this one, and escape and escape, it's defined. You see the properties. So this will act only on this one slab, because I have defined z is equal 0. On this next level, we have a sailing jump. So if I leave my coordinate system on this place and I would like to draw some another load, for example, over this full rectangle, and I start, leave the properties the same, I will change it later. So I draw the geometry from here, and you see whatever I click, then it's drawn here. I go here, and you see this green line. That means that the load will be drawn where is my XY coordinate system. So I will break it, move the coordinate system to this point, for example. It will be not correct for this one or this one, so I can move it only in these two places. So, and now I draw it. So escape, escape again, escape. So, and now it is defined that it acts only on z equals 0. That means this would be generated only on this part of the slab, but not of this one. If I want to generate it on more higher depth, then I have to change it, for example, to from to. From is the minus value. So, for example, from minus 10 centimeters to, this is 30 centimeters, so I go to 0.4. So, and now if I go to generate loads, then you see it's generated on both plates. So, if I would like to change it, then it's not available, because this is the generated load. If you want to change the load, you have to display the original loads. You can get it in right mouse button, view settings for all entities. So if you don't see these labels, you can activate the labels, load masses, and you have here original. So, moment, I make smaller, apply. This is this green one, or the generated, or the both, but sometimes if you display everything, then sometimes it's just mismatch. So I go to original. So this is if you want to generate it on more nodes. On this third floor, I will generate also one. First move the coordinate system to this point and generate the load, -3. Doesn't matter, I select only this geometry, for example, escape, escape. So, and here is z equals 0. So I will change it. I change it to all. Then I can change auto to select. And now I see this action button, update to the members selection. This is visible only if you select one free load. If you select more free loads, then you can, of course, not change the selections for more loads at once. So, and then you can click on the plate. So then it's not depending on the height, on the area which you selected in plus z or minus z or z equals 0 or all or this from 2, but only your selected plates which you have selected will be loaded. So now the calculation we can start the calculation. It's not necessary to run the full calculation. You can simply run the test of input data. This is enough for the load generator. I hope it was in the past. So go to view settings, load masses, and change it to generated, apply. Okay, so now we see all the generated masses. This is a wrong load case. So then go back. I go to original, apply, select all these loads. You can select, for example, right mouse button, say expand selection, then all loads which acts in that direction will be selected, and we change the load case to G2. And now I go to Q1, for example, and I would like to load all the slabs with some chess-like distribution of the load. So one rectangle here, one here, and one here. What can we do? The load case, the coordinate system is on the top, that's okay. Go to the surface load. Z is equal 0 is wrong. I go through all. I want to load the full structure. So, and I can work with rectangles, for example, one here, and one here. So now it will be generated through the full structure, but all in one load case. So I would like to change these two to Q2. Now we have Q1 and Q2. Okay, and after the calculation or test of the input data, I can switch to the generated loads. Right? So, and you see the Q2, it's through the full structure, and Q1 on this one small rectangle also through the full structure. You can check the results of this load generation in the results. So first we have to run the calculation, but this test of input data is activated. So if you click on linear analysis, then it doesn't work. So you have to deactivate the test of input data, and then you can activate the linear analysis. Run the calculation, and now we can check the results. There are in results surface loads. You have to select the load case which should be displayed here, not here. This one displays the inputted or the generated loads, but not the results with the isobands, for example. So we change it to G2 and simply click on refresh. Then it's one value, it's gray. You can change in this drawing setup how it should be displayed, doesn't matter at the moment. So we can change the to Q1, for example, and also here, so then to have the same representation, and you see this is here and it's also here defined -3. Okay, if you would get another value, then it's here also displayed. And I can change, for example, Q1 and here also as a Q2 and Q2 and check the results. Okay, not very nice graphic representation because we have only one color. It's selected is gray, so it doesn't matter. You can check it here. We will see it a little bit better on the another examples. So I will leave these results, and we have some tasks which you will also get. For example, change the location, move or copy this load case, these loads, and also change the geometry. So I think the change of geometry is mostly important. So go to the load case G2, for example, and I would like, for example, to move this load case to the top. This is very simple. You can simply select it from here to here. It's moved also. Okay. There is also another function. If you move first your coordinate system, for example, to here, you can select the load and click on move user coordinate system, then it's projected on this layer, so on this level. Also, if it is rotated, then will be rotated. So you have to be careful a little bit with it, check it, but it's a powerful function. If you want to change the geometry, then simply select the plate, go to Edit Plane Load Geometry, and for example, I can move it here, and I can move it here, and then I have it over my full plate, and it's generated on the full plate. So if there is no geometry, then also no load. We have also another function. There is this polyline edit and add or delete node. I can change it, for example, to midpoints also, and I will add 1 point here, and that's all, for example. Then I have one node here, so I can select this one. So I have then node here, and I would like to add one node also here. So I do the same, modify, polyline edit, add node here, right mouse button, escape, and here, and escape. Okay, now I have some nodes, and I can go back to the edit plane load geometry, and you see these are these two nodes. So I can move this one and move also this one. So with this combination of polyline edit, and then the nodes can be moved with this edit plane load geometry. There is also this table edit geometry. I don't know if somebody will change it by coordinates, but this is very powerful if you have some parametric model, because you can add these parameters to these coordinates. So you cannot do it on another way. If you want to create parameters for free loads, you have to do it about this table editor. So, and I think that's all with these loads, and we can go to the next models and next examples. I have prepared few examples which you will get standard in your structure. So the first one, I would like to define water pressure on this I don't know, pond, or what is it, pool, swimming pool, for example. So first, what I have to do, I need a vertical plane. So I change the coordinate system with 3 points. The first one, second, third one. So I have XY in this plane. It must be in the plane of the wall. I can move it, for example, to 0, 0, and 2 meters. So it's outside of the structure. It doesn't matter. Then we will load with the local coordinate system of the walls. So therefore, I have to check the coordinate systems. Right mouse button, view settings. On the structure, there is somewhere local axis of 2D members, apply. Okay, so, and what we see is that this one goes into the pool and this one goes outside of the pool. So I change it so that all go into the pool. I think this is with this swap orientation. This is better because if you have some nonlinear calculations and then you have supports on the negative Z side. So if you get pressure, from example, from water from the outside, then will be the coupled from the earth. So the supports are on the negative Z side. So this, each time I do it so that the coordinates shows into the structure. So, and now I can generate the load in the local coordinate system of the wall. And I simply draw a rectangle. Where is it? I go to the basic modeling, to loads, and define where, for example, in this water pressure, define surface load. Doesn't matter, I don't change it. I only draw the geometry. Everything can be changed later. So I click on the geometry and you see it's drawn where is my XY coordinate system, right mouse or escape. It's defined. Okay. No, it should go not with the direction Z, from the global coordinate system, but from the member coordinate system. And we should get the pressure from to the outside. So it should act against the z-axis. So it must be minus. So it's minus, that's okay. And it's uniform, this is not okay. I want to change it, for example, in direction y. This is the direction, how was my coordinate system located during the drawing. So, and I have the first point, for example, is 3 meters. Okay, let's say -3, and the second point is 0. So, okay. And now generate the loads, and we have to switch escape. We have to switch the settings to the loads and to the, I will display both original and generated. So, and you see it's from inside to outside. This is my generator, and this generates the loads on my wall in local coordinate system of the wall. So, and on the other side, I have to do it on the same way. But this is therefore because I have selected auto. And if you select automatic and the projection of this wall to the plane of my load is 0 area, then it will be not generated. This is because if you generate the load on your slabs and you have walls, then also on these walls would be generated the loads. But you can go to the generation to, or the selection to select. Then I can go to select the plates, and I select this one, this one, this one. I can select also the floor, escape, then all will be loaded, and I can generate the load. And you see, I get the loads also on these walls and also on the slab on the bottom. So everything is loaded. So the same can be done also here. It's 3D, but it's the same principle. So I move the coordinate system, for example, to the middle of the structure. Then I will create a new load from these points. Let's say only in the middle. Oops. So from here and from here, we should get this point. Okay, escape, escape. So, and it's in member coordinate system. How is going my member? If we look at this structure, you see that is going to the outside, so I have to change the direction. Okay, so I have to load it with minus, and I get the same. If I go escape, I go to the load. Sometimes I push the escape on my mouse, sorry. Uniform. This is not uniform, this is in direction y from -3 to 0, and overall, that's okay. So we can generate it, and then you see the load. And after the calculation, we will see also nice isobands. So if we go to the results, I go here, surface loads, change the load case, and this is, yes, system is local coordinate system of mesh element. That's okay. So, but this is not very nice, this representation. How can we change it? Change it, for example, to smooth. What will happen? Okay, it's better. Then we get some values. It's different if you have some trapezoidal or triangular loads, or if you have only constant loads. If you have only constant loads, then these another colors are better. So that's okay. So if you are disturbed with these values, this is only the graphical representation of the loads. They are drawn with this rendering, so we can change it to simple. Then it's a little bit better. It's more clear. So, and then to the question of my customer, he have asked to put somewhere in the wall some vertical load. How can we do it? So usually the people start with horizontal coordinate system. I try to put it somewhere, but it doesn't work. So first you have to go with your coordinate system to the wall. From 3 points, first, second, third point. So I will leave the results. And now I would like to draw it somewhere here and such vertical force. Then I go to the 3-point load, is for example -5. It goes, I will say, no, I will select the wall. This will be better. Okay, and then I put it somewhere in the wall, for example here, escape. So now it's here, and I can now allocate this load. For this is not automatic, this should be through the selection. Update to the member selection is here, and escape. And now if we run the calculation, we can check the deformations. So it's generated, it has nice orange color. And if we go, for example, to 3D deformations, where the 3D deformations, here from my load case, water pressure, and refresh, then we have to get some, I select only one plate. This is all current. Refresh, it's better. It's almost zero, it's very small load, but you see the deformation is there. So this is the way how to define it. And I think this is everything for today. It should be not too long. Thank you very much for your patience. Thank you.